Hello everyone, I'm Xiao Gang. Let's take a look at TMap. TMap exists in our mapping as an associative pair of key and value types. In the previous chapter, we already covered TLV. Actually, TMap is slightly more complex than TLV, but what we really need to master is basically adding, deleting, modifying, and querying. As for other information, it's not really needed at this stage. If we need it later, we can come back and look at it in detail. That's fine too. No problem. Let's first talk about some more complex concepts. We'll go over them, just verify them. Then TMap and TCs. What we'll talk about next. They are quite similar. They both perform hash calculations based on the key. But you need to note that TMap is a key-value pair. That is, this key is used for storage and retrieval, and in blueprints we have used comping. We all know if a new key and an old key, their keys are the same, then the new key's corresponding key and value will overwrite the value in my key value pair. But if we sometimes have a need, we might need to store duplicate keys, we can use this TPair so the TMultiMap container can continuously store new keys and key value pairs, even if they duplicate the old ones. As for TMap, actually this key, it serves as a mapped element type, and actually it is in the form of TPair for pure management. So TPair actually, it has these two. It is a template, has two elements. One is the key, one is the value. We rarely reference this pair because this TPair, referencing it would be very long, but we will. During the loop, I will demonstrate to everyone we were looping before. We use auto to let it automatically deduce the type without needing us to write such a long type ourselves. And also note that it is a homogeneous container. Homogeneous container meaning its element types are all the same. That is, you cannot store different types. For example, if this is a container of int32, then it must be that its mapping is from int32 to f, k and value, right? Then you definitely cannot store it. The key value pair type is of the integer type, right? Then if it is a value type, then it might support this kind of copying, assignment, or destructive operations, as well as these elements. All strong ownership relationships. Then when it is destroyed, all elements must also be destroyed. So its keys and values are both value types, and it is a three-type container. It is a three-type container. So when we compare, when we store, we must support the typehash function. One show that it can know where to store it. Then we determine whether two keys are equal. So your key must support this operator and other auxiliary operations like that. This way, it can determine whether they are essentially the same. TMap can also specify its memory allocator. It uses a set allocator, right? Then because it's different, the underlying allocation is different from what TArray and others use. And what it uses is this kind of set allocator, mainly to calculate the number of these three-column buckets, how many buckets are available for us to choose, and then which one we use, memory allocation to store these three-column elements, and finally, if sometimes we don't want to override these things, if we want to define additional ones, we can specifically write a key function, then how to get the key from this element, and prefetch to determine the two branches. This is actually similar to what we covered in the previous chapter. Overload this operator externally. Actually, it has a similar effect, and they usually return a reference to this key. Then check for equality. And they didn't call the definitions defined inside our members. This getUpHighKey function has been calculating for 3 years, and also, then we note the biggest difference between it and TO. This is also a common interview question. It's a relatively simple question. Ask you whether you use TMap or TO more often in projects. Is TMap ordered? TMap ordering is neither reliable nor stable. You can just treat it as unordered. The order of addition and return are completely different, and it's also unlikely to be stored contiguously in memory. Then, one thing to note is that this TMap does not shuffle elements to fill empty slots, and pointers to elements may also become invalid. That is to say, you should be aware that when it expands, the entire memory and the positions of these pointed elements may become invalid. So that's roughly the idea. This concept is a bit tricky, but overall it's still very easy and simple to use. So let's stop here for this concept. In the next lesson, we will directly start doing a simple code reproduction